Okay, so this week we're going to talk about uh, transformations with dilations and rotations. Last week we were talking about reflections and translations, and this week we're going to do dilations and rotations. For dilations, it's just we just have to think about when we think about dilations, we're changing the size. So it's either shrinking or enlargement uh, of uh, of objects or figures. Here we're using translations in the coordinate plane, which is points like in a graph. So it helps seeing the transformations better. Dilations are just multiplication. So you're going to have a scale factor where you're going to multiply your scale factor. So say you have a scale factor of 3, you multiply 3 times x and then 3 times y, and then you get the new point, basically. That's a dilation. Or divide if you make it smaller. Rotation, these are the rules that we're going to be using. So just a little overview. This is your sheet that's in your Google Classroom. And on the bottom, you will see the rules of the rotation. So rotations are turns. And then notice that what it says here, it says rotations of 180 are equivalent to a reflection through the origin. So that's a pretty interesting note. You're going to see it right now with some examples that I'm going to do. Counterclockwise, remember, is going the other way of the clock, so this way, so to the left. Uh, Clockwise, it's going to go to the right, so it's rotating like to the right. Counterclockwise is to the left. So counterclockwise, we usually use either a negative or we say counterclockwise. Clockwise, we don't use a positive sign. We just use either clockwise or just a regular a 90 or 90 clockwise or 90 rotation, something like that. So it's positive. Uh, Notice that these are the same, so the same rule for some of them. So like 180 is gonna be the same rule counterclockwise or clockwise. So it's just a kind of a flip. It looks like a flip, a 180 flip. That's why they're the same rule because it's a flip. Notice that you switch the signs basically. A 90 and a 270. So a 90 counterclockwise and a 270 clockwise is the same rule. And notice that x and y is flipped here, and then y has negative. When he has negatives here, it means that it's multiplied by -1. So we're going to see this in some examples. All right, so first examples, we're going to be doing rotations. So let's do a rotation about the origin 180. With this, it says it's positive. So either positive or negative, in this case, it's the same. So our rule is xy goes to -x and -y. So that means that our signs of my points are going to be switching. So let's find the points first. So that's 5 to the right, 2 down, y. All right, the next point is B, 1 to the right and then 4 down. B, 1 to the right and -4 down. W, it's 1, 2, 3, 4, 1, 2, 3, 4. So that's W is 4 to the right, 4 down. These are my points. So now I'm going to perform this rule. X and Y goes to -x, -y. And that's my rule from my sheet there. All right, so my new points are y apostrophe, -5, and then +2. I just switched the signs for each. B apostrophe, my new point is -1, +4, and then W is -4, +4. So let's look at where it is. Let's find it. So that's -5, 2, -5, and then +2. B is -1, 4. 1, 2, 3, 4. And -4, -5, -4, +4. So that's over here. And that is my figure. Now notice that it looks like a flip about the origin, which is nice. It's a reflection about the origin. Also notice that it turned twice. So it turns one turn. So if it was up here, it's a 90 degree, 180. Three turns is 270, and one whole turn around is 360. So it should be, so a 180 is a flip. So it's a 180. So a one turn is 90, 180, 270, and 360. All right, so let's do another one. Let's do a 90 degree clockwise, this figure, which is kind of on top of that origin. Okay, let's find the points first. So E is -1, 1, 2, 3 up. R is 0, 1, 2, 3 up. K is 1, 2, 3, 1 down. And then T is 1 to the left and then 1, 2 down. All right, so now I'm going to perform the transformation. I'm going to look first to my sheet to see which rule am I going to be using. This is a 90 degree clockwise. So I find clockwise and then 90 degrees. So this is the rule that I'm going to be using. So Y and X are flipped, and then the one X is going to be negative. So the one that becomes Y is going to be negative. All right, so let's do that. Y and then negative X. I'm going to write it here. That's X, Y goes to Y, comma, negative X. So they're flipped, and then it becomes negative. So let's do that. So E is, so let's flip them first. So that's 3 and then -1, right? But then this one changes the sign. So really it's going to be a positive. All right, R. It would be flipped, so that's 3 and then 0. But in this case, because this one switches signs, 0 does not have a sign. So you don't use signs with 0. 3, so that's K apostrophe, that's -1 and 3. And then the other one changes sign, so it becomes negative. And then T, it's -2, and then this one becomes positive, so that's +1. That's my new point. Let's look for it. So 3 plus 3, 1, 2, 3, 1 up, and then 3, 0, 3 0 is over here, and then -1, -3, so -1, and then -3, 1, 2, 3 is over here. And then -2, 1, -2, 1, it's over here. So that's my figure right there. It's turned 90 degrees clockwise, like that. Whoop. Looks good, right? All right, let's do one counterclockwise. Let's do this one. So rotation counterclockwise about the origin. Let's look for the points first. So that's E is -5, 1, 2, 3. So that's -5 and then 3 up. T is 1, 2, 1, 2, 3. So that's -2, +3. U is 0 and then 2 up. And then R is -5 and then 0. Okay, so now I'm going to perform a transformation rotation counterclockwise 90 degrees. So I'm going to look in my sheet and I'm going to look for counterclockwise 90 degrees. This is the rule. So my X and Y are flipped, and then my Y changes signs. Okay, let's do that. I'm going to write this down. So my rule is X and Y goes to counterclockwise 90 is -Y, comma X. All right, so it flips. And then it becomes, and then the value for X becomes the opposite sign. All right, let's do that. So that's E, and then it's flipped. And then this one, because it's positive, it becomes negative. T. I like to flip it first. So that's 3 and negative 2. And then this one becomes negative because it's positive. See? U. I like to flip it first. And then this one is positive, so it becomes negative. And then R, 0 and negative 5. In this case, 0 does not have a sign, so we just leave it like that. All right, let's look for this point. So negative 3, negative 5. Negative 3, 1, 2, 3. Negative 5 is down here. Negative 3, negative 2. 1, 2, 3. 1, 2. That's here. Negative 2, 0. And then 0, negative 5. So 0 and then negative 5. 1, 2, 3, 4, 5. Here. And that is my figure. So it was turned 90 degrees counterclockwise this way. All right, so with that, I'm going to do some examples for dilation now. Remember, for rotations, please use these rules. Okay. So dilations. Dilations, I don't need the sheet. Dilations are just multiplication. So in this case, I chose some with fractions and decimals, but you might just have a number. So I'll change this one to 3, so you know that there is a pretty common one that it's used 3. This one, it's going to be a division, right? Because it's a fraction. So it's like a quarter of this. So you're going to be like shrinking that thing. All right, so let's look for the names first. I mean, the points first. So that's C, and then that's 2 to the right, 0. Y is 5 to the right and negative 1 down. And then I don't know what that is. I think it's L. It's 1, 2, 3, 1, 2, 3. So that's 3 and then negative 3. And then it says a dilation of 1/4. Well, we just have to divide this by a quarter. It multiplied by a fraction is like dividing, right? So each of them are going to be divided by, it's going to be multiplied by 1/4. So let's do that. So let's do it here. So that's C, and then 2 times 1/4. And then that's my X, and then 0 times 1/4. That's my first point, okay? My second point is Y, and then it's 5 times 1/4, comma, and negative 1 times 1/4. Notice that I'm multiplying. And then L, my point L is 3 times 1/4, comma, and then negative 3 times 1/4. So my new point is 2 times, so that's 2 times 1 is 1 divided by 4, that is 1/2. So point C is 1/2. 0 times that is 0. Y is 5 times 1 is 5 divided by 4 is 5 over 4. And then negative 1 times 1 is negative 1 over 4. It's negative 1 over 4. My next point is L. And then is 3 times is 3/4, comma, and then negative 3/4. And those are my new points. So notice that it's going to be shrinking, right? Okay, so let's do another one. Let's do a dilation of 3. Let's do this one. Okay, so let's find the points here. So that's 0, 1, 2, my first point. I'm going to put whatever letter there because I have no idea what letter that is. Let's say this is A. So A is 0 and then 2 up. D is negative 1, 0. And then Z is 2 and then 1 down. Okay. Now I'm going to perform the dilation, and it says dilation of 3. That means my scale factor is 3. So each of these are going to be multiplied by 3. So A, it will be 0 times 3 on my x. This is my x, this is my y. And then 2 times 3 on my y. That means that A is 0. 2 times 3 is 6. Okay? D. D is -1 times 0, times 3, because that's the dilation factor, and then 0 times 3. D is -3 and 0. You're just multiplying each of them. So both x and y are going to be multiplied by that scale factor. And if you're multiplying by a fraction, then you're dividing, right? All right. You can use a calculator too. My z is 2 times 3 and -1 times 3. 2 times 3 is 6, and -1, that's -3, and that's my new point right here. So if we look for these new points, let's look how it looks. So that's 0, 6, 0, and then 6 up. So that's going to be like up here. My other point would be -3, 0. So -3, 1, 2, 3, and then 0 up here. My other point would be -3, 0. Yep. 6 and -3. 6 to the right and -3 down. So it's like right here. Look how it's big. All right, so it just went in size, huge. And that's it. So I hope this helps.